In this video, we'll continue adding user-defined statistics to the healthcare and the emergency department model that we left off with in the previous video. One thing I wanted to mention that I forgot to do in the last video when we constructed the model was to set the priorities, the ranking rule for the doctor and nurse resources. So we have the doctor and nurse resources that are required to do the treatment once a patient arrives at one of the rooms, and we prioritize those based on the patient data priority. So the patient data priority table specifies urgent patients have the highest priority, and we had already done that with the rooms. In the previous video I just forgot to do it for the doctor and nurse resources, so make sure that you do that in your model. The next user-defined statistic that we're going to build is a state statistic, and so if we go to the model definitions elements, we see the state statistic is used to record a time persistent statistic on a state variable. And so what we want to do is track the number of patients in the system at any given time. And so we know that Simio by default tracks by object instance, but what we want to do is keep track of the total number of patients in the system. So here's what we're going to do. We're going to go to the definitions page and add a state, an integer state called num patients. And we're simply going to increment this when a patient arrives and decrement this state when a patient departs. So I'll go to my source, and on the state assignment, before exiting, I'll simply increment that model state, so num patients, and the value is num patients plus 1. So we just increment the value when a patient arrives. Similarly, when a patient departs, I'm going to decrement that value. So I will go to state assignments and add the corresponding state assignment, num patients equals num patients minus 1. And so now when a patient arrives, we increment the value. When a patient departs, we decrement the value. And so at any given point in simulation time, the value of that state should be the number of patients in our system. So to define the state statistic, we simply go to the elements page, state statistic, and let's name the state statistic num patients in system. And then we specify which state variable we want Simio to watch. And so we want the one we just defined, num patients. And so this says I want you to create a time persistent statistic based on this value. So if we go back to our facility, and if we now run in fast forward mode for our single replication, and then go look at the results, we can see the new statistic right here, num patients in system. And we see the average final value and maximum. And so because the final value and the maximum are the same, we know that when the simulation terminates, it's at maximum value. And if we look at the average, it appears to be approximately 1/2 of the final value. So that's some pretty strong evidence that we have a continuously increasing number of patients in the system, and we probably have a system that's unstable. And if we increase the capacity, we can probably fix that stability problem. So for example, if I increase the number of nurses from 3 to 8, and then I rerun my model, and then I look at the results, we see now that our average value is much smaller, our final value and our maximum are not the same, and so we have some evidence that we have fixed the stability problem. Of course, we've only run one replication, and so we really can't draw any conclusions from this. We just have a little bit of evidence to move forward with. So in looking at our model, we have the resource capacities, as we talked about, and in our tally statistics, we're tracking the waiting time by patient type. And we have a clear relationship here. If we want to reduce the waiting times, we simply increase the resource capacities. So we need a way to trade off the increase in resource cost with the reduction in patient waiting time. And so we use an output statistic to do that. So an output statistic is the third basic type of user-defined statistic, and it records the value of an expression at the end of a replication. And so we're going to define our cost term as follows. We're going to define something called cost, or total cost, and we're simply going to or add a cost for each unit of capacity for our resources, and then we're going to penalize by also adding costs for the total patient waiting hours. Now, these numbers are fairly arbitrary. We just made these numbers up. I have no idea whether these are reasonable in the healthcare industry. But in order to implement this as an output statistic, we need to first define this total patient waiting hours, and then we need to define our output statistic. So we can do that in our model. Let's go back, and in the properties, in the state definition tab, let's add a real state called total wait. Total waiting. And so what we're going to do is, in this state, we're going to record the total amount of waiting time by all entities so that we can use that as a penalty in our cost function. And so we can go back to our facility, and at this point in the normal exit, what I'm going to do is have an add-on process, and when an entity leaves, I'm simply going to assign the value total waiting is the previous value plus the entity's waiting time. Model entity waiting time. And so when an entity departs, we will simply increment the placeholder, our total waiting time, by the waiting time that this particular entity that's exiting the system has accumulated. And then finally, in the definition, we will define our element output statistic, and let's call this total cost. And then we need to put the expression in. So the expression that we have is the resource cost. So we have 2,000 times exam capacity plus 2,500 times treatment capacity plus 4,000 times trauma capacity plus 4,000 times nurse capacity plus 12,000 times doctor capacity plus 250 times total waiting. So if I type that all in correctly, let's check it out. We have still needs some more room on the screen. 2,000 times the exam capacity plus 2,500 times the treatment capacity plus 4,000 times the trauma capacity plus 4,000 times nurse capacity plus 12,000 times doctor capacity plus 250 times total waiting. And total waiting is measured in the default time units, which are hours. And one other thing I want to do here is I want to divide this entire expression by 1,000. So we're just tracking in thousands of dollars rather than individual dollars. And so now we have this output statistic called total cost. And when I go back to my model and run my model, so we'll run again in fast forward mode, then we can look at our results, and we now have a new user-defined statistic called total cost, which has the total cost of the given configuration. And so for example, if we remember that 334.8 number, and then I go back to my facility and say change the number of nurses back to 4, let's say, and then I run my model again, and I go to the results. Now we have a total cost of 6,000. And so when we look at our patients in the system, we can see that we potentially have an instability, because again, the final value is close to the maximum, which is about half of the average. And our cost now reflects that, because we have a significantly increased cost relative to the previous configuration. Of course, we've done absolutely no experimentation, and everything is that I'm saying is based on a single replication. And in the assignments to this module, you'll have an opportunity to do some additional experimentation. And in the next module, we will talk about output analysis and how to actually use this type of model to solve resource allocation problems. And so in summary, for our model, for the module, what we've looked at is 3 basic types of of user statistics, the tally statistic, which is what we looked at first. And a tally statistic, you basically record a value, so you determine what value you want to record, and then at the appropriate point in simulation time you record that value, and then Simio reports the statistical results. We have a state statistic where we define a state and we update the state accordingly, according to the logic of the model, and then tell Simio that we want a time persistence statistic on that state. Finally, an output statistic tells Simio at the end of a replication, report a given value for a given expression. And so I think you'll find user statistics are quite powerful in Simio, and you can use them to determine values, determine performance metrics that Simio doesn't provide by default.